So welcome to all of you to today's Nexus seminar, which is co-hosted by WEFE. This is the United Nations University Institute for Integrated Management of Material Fluxes and of Resources, and the Dresden University of Technology, the TU Dresden. In particular, PRISMA, which is the Center for Sustainability Assessment and Policy. Professor Manthi Dijkstra Silva is the Karlovitz Junior Professor for Sustainability Assessment and Policy, and she represents TU Dresden in PRISMA, and she also co-hosts with me these Nexus seminars. My name is Irena Kutsia. I'm from WEFE, where I'm responsible for anything or everything related to education. And we present this under the umbrella of the Knowledge Academy for the Resource Nexus, which we call KARE. And I'm very happy to welcome you all today. Also with us today is Asha from WEFE. She will help with technical support. You can just write in the chat if there's anything she can help you with. Some background about the Nexus seminar. The series was established in 2015, and it features speakers, usually senior researchers, on the topics of sustainability and the resource nexus. In other words, the integrated management of environmental resources so that synergies and trade-offs can be identified and leveraged. Apart from the public audience, we also have students in the lecture today. They have to complete a learning diary about the Nexus seminar series held in this semester, and they will have to record or report about what are the three main insights of this lecture, how can their and other disciplines contribute to the topic, and which other disciplines can contribute and how. So today's seminar is number 87, and like you see, we will have Professor Ali Rhouma presenting to us today. Before we start, just a brief orientation for the participants in today's session. The speaker will start with a presentation of their work. If you have questions for the speaker, you can post them in the question and answers section. It's a panel there at the top, Q&A. I will moderate the discussion and the questions after the presentation, and we will read your questions on the panel and the speaker will answer them from there. Should you encounter any technical difficulties, please do not use the Q&A session panel, but the regular chat function where you will reach a colleague. This is Asha, who is assisting with facilitating the session today. So without further ado, I would now like to introduce Professor Ali Rhouma. He is a project officer at the PRIMA Foundation. That's the Partnership for Research and Innovation in the Mediterranean Area, PRIMA, responsible for nexus in water, energy, food ecosystems in this area. So he has long-standing expertise and understanding the complex interplay of energy, water, food nexus policies in the Mediterranean region. His research work has significantly contributed to the adaptation of farming systems, which are now very much challenged by climate change. He has more of 20 years of experience in this kind of agricultural research, and he previously also worked at the Ministry of Agriculture in Tunisia as the director of the research department. And that's only a brief synopsis from the CV. Today, he will talk about WEFE Nexus Indicators for assessing sustainability in farming systems. And we are very much looking forward to your presentation, Ali. So I'm handing over to you. Thank you.
Thank you so much, Serena, and thank you for this invitation. It's my pleasure to share with you what has been achieved so far in the Mediterranean. So today I'm going to bring you on like a brief journey on what has been achieved on terms of the sustainability in farming system. And today I'm going to summarize 2 or 3 publications, one on the environment and sustainable indicators, which has been published like 2 or 3 months ago, and a very new updated article published recently on the cleaner environment system, a book chapter in the Mediterranean, which is published last year. And also, I will shed light on new articles, which is basically linking the agroecology assessment with the WEFE indicators. So let me share my screen. I believe you can see my screen, Serena.
Yes, we can see it in presentation mode. Thank you.
So yeah, as said, Serena, so today my intervention is about the integration of the WEFE Nexus Indicator for the assessing the sustainability in farming system. And during this my presentation, I will maybe take you in different directions here. I will start by short introductions, and then I'm going to present the sustainability in farming system, how to measure the sustainability in farming system, which is basically a little bit challenging, how to measure the sustainability. And we know that since more than 20 years ago, several scientists are trying to measure and implementing different indicators to measure the sustainability. I would like to also highlight on the agroecology, because there is a lot of indicators on agroecology, and what I did here, I would like to see the correlation between the agroecology indexes and the water energy food ecosystem nexus. And the last point is about the framework of the WEFE Nexus to assess the sustainability of the farming system. Here, I think it will be very useful for you because we use the different approaches. The first one, we rely on the water footprint, but also the water scarcity footprint, because in general, the water scarcity footprint is a little bit overlooked. And the last, important tool for assessing the sustainability of the farming system is the SDM, or the system dynamics by modeling. So let me start by a quick introduction. As you know, agriculture land in the world encompasses both cropland and permanent meadows and pastures, which is basically, spans around 4 billion of hectares. As you can see, this is it has been taken from the book which is published recently by FAO. And you can see here that for 0.8 billion of hectares, which basically, represent 1/3 of the world land area. So you see here also the forest land, which is basically 31%, and the rest you can see the Arab land, also the temporary crops, and also the fallow, the meadows and pastures, and the permanent crops. So the issue that the global, agricultural productions, as you can see here in these two slides, the primary crop production growth rate is variable, and you can see during the last year, this rate is a little bit lower if you compare to 20,000 or also more recently 2010. But we can see that more or less the food production, or we can say the agriculture production in general, is now it's around like 10 billion of tons. But the major part, as you can see here in this slide, mainly the cereals and sugar crops, which is represent together is around roughly the half of the agricultural production. And these are data from the FAO published recently in 2024. As you know, that agriculture, we have this a lot of challenges, but here I would like to highlight the most important point here, the contribution to the greenhouse gas emissions. So basically what we know that the energy transport industry are the main producer of the greenhouse emissions, but also would like to bear your attention that agriculture also could produce also greenhouse gas emission. As you know, that agriculture, it helps to sequester the carbon, and also it's more the adaptation, but also agriculture, could produce also great greenhouse gases. So together with the forestry and land use, it's around like 24%. And basically, as you can see, for the agriculture, this 12% comes mainly from the enteric fermentation, which refers to the methane emissions produced during the digestive process of ruminant animals, cows, sheep, etc. So, agriculture could produce also a greenhouse gas emission. Even we know that it contributes also to the carbon sequestrations. What I would like here also to highlight that the agriculture, as you know, it produces like 12% of the greenhouse gases, but it also is the most vulnerable to climate change due to its dependence on the climate patterns. You see here, this is a slide from the IPCC, and you can see this is the cascading impact of the climate change to different components of the farming system, from the yield to the pests, to the diseases, to the food prices, malnutritions, to the soil. So it's basically cascading impact of the climate change, and we cannot target the agriculture in different components, but we need to look at this agriculture as a system. So the agriculture system is basically the connection between the biophysical resources and also the socio-economic context. So we cannot look only at the biophysical resources, the water, the energy, or the food, but we need to look at the entire system, because, as I said, the impact of the climate change is a cascading impact. It touches all the components of the system. So what I can say here, the agriculture is basically a socio-ecological system, and developing response strategies to climate vulnerability for agricultures. We need to understand the complexity and the dynamics of the different components of the system. So you see that, and this is we are looking forward to implement the WEFE Nexus, because the WEFE Nexus considers all the different components of the system. So it has been recognized, this system, for the sustainable agriculture since decades, and the system theory and the system perspective remain a little bit limited, if I can say, in terms of the application, and in terms also on the interaction between the different actors, between the different components of the system. And that's why there's a lot of indicators and a lot of research that are doing a lot of efforts to try to assess the sustainability of the farming system using different indicators. What I would like here, before going to the indicators, and this is very important, because, as you know, agriculture, if you would like to produce more with less, and to sustain the agriculture system, there are 3 levels of the adaptation, and we need to bear in mind that we are not only on the first, the incremental one, but also with the impact of the climate change, as you know, now in the Mediterranean, or also in other regions, we are experiencing the impact of the climate change, and I think we need to well prepare it, because without any adaptation, without any transformative adaptations, we will have a lot of issues and a lot of challenges to tackle. So basically, 3 main important, levels of the adaptation to the climate change. The first level is the incremental one, when we can also talk about the varieties, the different, plantation times, etc. So we are touching only some components of the system. So we're not targeting the system. But once the climate and change will have an impact, so we need to move forward to the adaptation of the system, which is basically the second level of the adaptation. But also we need to also now move to the transformative adaptation. As I said, with the impact of the climate change, I believe that the 3 levels deserves to be considered, not only in the Mediterranean, but also all over the world. So if we will not, consider this transformative adaptation, we will have a lot of challenges, and of course, this will be reflected on the production, or as well on the quality of the products. So, as I said, this is just a very short introduction, but now how to assess, how to demonstrate that we are in the sustainability in farming system. So basically, as I said, we have different components of the system, and we cannot target only the biophysical resources, and we need to focus on the different components of the system. So basically, as you know, the sustainability indicators, we can split them into different, indicators here. the economic indicators, the environmental indicators, and the social indicators. So basically, the two most important indicators, the economic and the indicators and the environment indicators, we have a lot of indicators, and people are focusing more on the two first components of the indicators, but the social indicators are generally overlooked by institutions, even by researchers, and this is the one of the main weaknesses of the indicators, whether implemented in different contexts or also in different systems all over the world. So what I can summarize here, the three main dimensions of the indicators, the economic indicators of the sustainability of agriculture. These are indicators like mainly based on the accounting data, meaning they capture the accounting profile rather than the economic profile. Here, what I can say that the most important ones are the productivity indicators. Productivity indicators are important because they are clearly advantages, because they assess mainly in particular the outcomes based on the use of the production factors in the farming system. Then we have the ecological indicators. A lot of researchers, there is like a huge research on the ecological indicators of the sustainability indicators. So what I can see here, and coming back to the what has been done like more than 20 years ago, and researchers are focused more on the how to assess the agroecological system. As you know, the agroecological system is in between, the conventional and the organic farming system, and the attention has been given to several indicators of agroecology. Just maybe to look and to see and to search in internet, you will see different indicators of the agroecology. One of the indicators, as you can see here, proposed by FAO, is the TAP, which is basically the tool for agricultural performance, that has been, used by different researchers, and it has been implemented to assess the transition or the adoption of the agroecology. But what I can see that according to what has been done also in different regions, several researchers, they use this TAP U tool based on the FADN database. The FADN database is basically the Farm Accountability Data Network, which is basically this database is in Europe, but it's not present in the southern Mediterranean, for instance. And now this database is used as like starting points to assess and to establish indicators of agroecology and to assess the sustainability of the farming system, but as well it is used to assess the adoption of the agroecology. And as you know, maybe some of you you have assessed maybe at small scale. We are not in the full adoption of the agroecology. Still, we have an issue of the agroecology adoption for different reasons. It's not only for the technical point of view, but also if we look at the socio-economic components, if we look at the governance, if we look at the policies, we have a lot of challenges because what has been done from the technical point of view is there, and then we are missing also the other components. The socio-economic components is very crucial to advance and to facilitate the adoption of the agroecology. I will maybe speak on later on about this green water footprint, because basically all the policies that has been have been implemented are more focused on the blue water footprint, and the green water footprint, which basically represent the most important water for the food production, is completely, if I can say, overlooked by different policies, and policies are more oriented on the blue water footprint, which basically represents like 15 to 20% of the total water footprint. So the main important tools that have been implemented, these are the main important tools. There are other tools, of course. So the TAP, as I said, the tool for agriculture performance evaluation, which is basically used at the farm scale level. It has been, now the tool is available and it has been implemented by the FAO. The WEFE, which is basically the original agricultural survey and indicator system, which is basically a little bit large from the, it has been implemented at the system scale. But, this WEFE, it is there is another tool called the IDEA, which basically the farm sustainability indicators, which is linked to WEFE. But if we can go to the landscape scale, the main agricultural structure index, which is basically this indicator goes beyond the farm level, and then try to involve the landscape, the natural landscape which is surrounding the different farming systems. So we cannot look at the farming system as a production system, but we need to look at the surrounding system, to the natural system, to different species, the forest, etc., to see how the agroecology system is, sustainable in this farming system. You can see here from the different index that some indicators are more focused at the farm level. Other are a little bit larger. They go a little bit larger than to the system scale and to the socio-economic component, but also larger. We can have the main agroecology structure index, which is basically very important to assess the transition of the agroecology, but also the sustainability of the farming system in general. We have already tested, in the Mediterranean, all these indicators, and maybe I will try to shed lights on this importance of the correlation between these agroecology index and the WEFE Nexus. So you can see here that for some agroecology index, it appears that some of them are more focused on the ecosystem aspects, like the biodiversity, like the intercropping, etc. But they are more focused on this component rather than considering the other components like the energy. For instance, it's not like very well apparent on the agroecology indexes. The scale also, it's very important, as you can see, and I already presented 3 levels of agroecology indexes, and several of them, if I can say, except for the main agricultural structure, is basically more large on the is considering the scale larger than the farming system. So most of the agricultural assessment index are more focused at the farm scale level, and which is not appropriate, because the Nexus should play an important role larger than the farming system in itself. Another important point that we have realized, that the agroecology indexes, they do not explicitly study the trade-offs and the synergy between the different components of the system. And this is, of course, is central part of the Nexus approach, because, as you know, the strength of the Nexus is not to the interlinkage of the different sectors, but to assess the trade-offs and the synergy between the sectors. So you know that the main important point of the Nexus lies on this assessment of the trade-offs, of the synergy, but as well to link the socio-economic components with the biophysical components. So the social indicator, as I said, so I started by the economic and the environment and the social indicators. As I said, the social aspects, the social indicators are overlooked in the literature as well in the different organizations. So here you see one of the publications, the last publications of Simeon in 2025, and you can see the different indicators of the social indicators, the age of the farm folder, the age of the farm manager, for instance. And we believe that we need to work on the social indicators. Just maybe if you can look at the FADN database, one of the weaknesses of the FADN is that we don't find a lot of indicators that addressing the social sustainability. So if you would like to use this database, which is basically this database is in Europe, so we have to be careful if you would like to assess the social component, the social indicators. You need maybe to complete your assessment using other indicators that are targeting the social indicators. So what I can conclude here that for this part of the sustainability indicators for assessing the farming system, that the economic dimension weaknesses here, they are focused more in the accounting data, and they ignore the opportunity costs, in particular the value for the family labor, or also the self-owned land. But also they lack indicators on long-term financial resilience, which is basically very important. The ecological dimension, what we have realized that many indicators sometimes are not consistent. We know that several of them that are linked to different greenhouse emissions. Maybe it could be like carbon footprint, fertilizer use, or maybe water efficiency, water footprint. But what we have seen that they are not sometimes standardized. So different methodologies, and our feeling that we need to standardize all these indicators linked to the ecological dimensions. But also the harmonized methodology, that also is very important, and we need to work on this harmonization of the methodology, which is basically linked to the standardization of the methodology used for the ecological indicators. The social dimension, as I said, this is it's the least developed of the three dimensions. And I think even for some database available right now in Europe, like FADN, we need to work on this social dimension, because as I said, the farming system is not only on the biophysical, on the economic, but also the social dimension is very important. So we need to find a way. We need to find other metrics, indicators to assess the sustainability of the farming system. Of course, the WEFE Nexus, the Water Energy Food Ecosystem Nexus, and by the way, with our colleagues from University of Flores, now we are preparing a new definition of the Nexus, and we will move from the WEFE to the resources Nexus, because we believe the Nexus, that we have a lot of resources. It's not only the water energy for the ecosystem, but other resources like the wastes, materials, and other resources deserves to be seen as important resources for the Nexus. So, we need the Nexus because we have a lot of assessment tools, but we have seen that the economics, ecological, social, and maybe they are all following the silo sectors. We have an issue with the standardization, with the harmonizations. The social data, as I said, it's basically also an issue, because it has been overlooked also by different studies. The integration and this assessment of the trade-offs and the synergy, but last but not least, also the weak policy relevance. And it's very important, as you can see, that we are not always in the part of the biophysical or the socio-economic. What also we need also to the governance and policies, because these are the main important pillar for the sustainability and for the resilience to the farming system. So this is a slide from what has been published in 2018, and it demonstrates the linkages between the different resources, but also between the different SDGs. As you can see here, between the different resources, there are different SDGs, and the nexus could tackle the interlinkages between the different resources, whether with water and materials, or for water and energy, food, land, all these interlinkages. And I believe that this is in the heart of the WEFE Nexus, because we cannot maybe also implement the Nexus without looking at the interlinkages between the water, energy, food ecosystem Nexus, on all the resources Nexus in general. What we published last year in MEDEC, in the Mediterranean. Just maybe to summarize here, and as I said, we are now pushing towards the implementation of the WEFE Nexus and to align the policies, because, you know, policies, governance, you know, and the the interlinkage management of the resources are maybe working together, and we cannot separate all of them. We have different, you know, drives of change, you know, the drives, you know very well, all the different drives from the climate change, all these urbanizations, the pollution, etc. But also we can have some adaptation solution that we could maybe implemented in the WEFE Nexus. When we implement the WEFE Nexus, we need adaptations and mitigation solution to reduce the trade-offs and maximize the synergy. But also we need the governance and institutions policies. This is also is very crucial, because without aligning policies, without thinking about the governance, how to work together, different departments, different ministries, we need to say build channels. Sometimes I heard that we break the silo. No, we need to build channels between the different silos, between different resources, because this is one of the main component of the nexus, and the outcome of this is the security, the water security, the energy security, the food security, but as well the health environment, because the health also is very important. The One Health concept as well is an impact of a good integrated management of the resource, which is basically to reduce the trade-offs, maximize the synergy, and also align the policies. So without aligning the policies, without thinking about the governance, I don't think that we will go further, and we will try to do our best to translate and also to facilitate the transition to the agroeconomy and the contribution to the sustainable development goals. Here I represented the nexus-based adaptation approach, which is basically the nexus approach, the fact to implement the nexus approach with, facilitate the adaptation through the sustainable use of the resources, which basically could be reflected at the policy level, at the adaptation plan, the NAPs, the policy climate, and all the policies, NDCs, etc. Look at the NAPs, the National Adaptation Plan, or the NDCs. Sometimes you are struggling where the nexus is implemented and thus in these policies, but also one of the impacts is the economy efficiency, the social equity, and the environment sustainability, which basically will lead to the sustainable adaptation and the contribution to the SDGs. As you know, now we are even struggling to contribute to the SDGs. Very difficult, to demonstrate that we are contributing to the different sustainable development goals. So let me move now to what has been achieved so far in terms of indicators of the water, energy, food ecosystem that could be used to assess the sustainability of the farming system, whether in the Mediterranean or outside the Mediterranean. This is basically an article that we have published this year, and our idea here is how to connect the water footprint with the WEFE Nexus, because several people that was using the water footprint with the two components, of course, the water footprint and the water scarcity footprint, but we are missing this connection between these components and the WEFE Nexus. So as you can see here that the connection is very important, and what we are looking here at two schools, basically. The school of orchestra, which is basically more focused on the quantitative water footprint. You can see the water footprint network, and you can see all the quantitative water footprint all over the world. But also another school, which is basically the qualitative oriented water footprint, which is the water scarcity footprint, the LCA, the water footprint. So we have different, two schools, and our idea is to assess the linkage and the correlation between the water footprint and the water scarcity footprint methodology within the framework of the WEFE Nexus, and try to find Is there any linkages? Is the two components, these two approaches contribute to the WEFE Nexus? This is what we have studied in this article. So as this is what we try to represent here. In the right is the School of Orchestra EOL in 2011, and there's a lot of articles. This, the water footprint has been, cited by different and several articles. And Orchestra, I think, it did a great job in this, water footprint, this volumetric, water footprint. And the left is the, the other school, which is basically the water scarcity footprint, basically more focused on the blue water. And they're using the LCA, the life cycle analysis, because they said we are not completely on the quantitative. We need to look at the whole value chain and to look at the LCA water footprint. And these two schools, sometimes they have some issue how to to discuss together and to find the way. So we believe that we find the solution, that it could be the nexus could maybe the bridge between all these two different two schools. So let me try to maybe highlight an important here points that we have demonstrated in this article. The water scarcity footprint, all over the different studies, we find a lot of water footprint, but the water scarcity footprint, it's a little bit overlooked, if I can say. So the water scarcity footprint measure how much pressure our activity put on our local water resources. Very simple, as you can see here, the EMD, what is left after when we deduct the consumption for the human and when we deduct the consumption for the environment. So this is basically what we call the EMD. And the EMD, then if you divide, the EMD for the world average to your EMD, whether at the watershed or maybe at the country level, then we can define the characterization factor, which is called the CF. So you see in the literature that there's a lot of publications, and also we have a lot of database on the CF, even by crop or also by country. So basically, the water scarcity footprint is to multiply, this the blue water footprint, which is what we have in the in the groundwater, what we have in the dams, etc., by the characterization factor. This is the water scarcity water footprint. Just maybe to make it easier for you, these are two countries. The first country is the country which is the country A, and the second one is the country B. So the A, we have the availability, so they have a lot of water. Let's take this, just an example, 2,000 of cubic meter per month, and the B is only 800 cubic meter per month. Human consumption, you see, for the two, 500, 600, environmental water requirement, 200, 150. And the area, I took the same area for the two countries. Now we would calculate the EMD. You remember the EMD, we have to deduct from the availability what has been consumed by the human or the environment. And we have to divide by the area. So what we can find here, 1.3 cubic meter per square meter per month. For the country B, it's 0.05 cubic meter per square meter per month. So now this is the EMD for the two countries. And if we take 0.5 for the average of the world, so we have to divide 0.5, which is the EMD, the average for the world, by the EMD of the country A and the EMD of the country B. What we can find, the CF, the characterization factors, it's higher, here for the country B, which is 10, but for the country A, it's like 0.38. So here we can say, once you find that your characterization factor is low, so you have plenty of water available, you don't have any scarcity, you have no problem. But if your characterization factor is high, then you have to be careful. You are in the scarcity, and this is very important, because if we are importing water from a country with the characterization factor very high, you have to be careful, because one day it will be a problem if they will face water scarcity and they will not produce what you are importing, it will be challenging for you. So, and I will, you will see here for the Mediterranean, what we have published, that the characterization factor and the quantity of important, products here, as you can see here in the Mediterranean, the characterization factor is a little bit, high. So we have an issue of the water scarcity here, but also in other region, you see, it depends, of course, on the country. Each country has its, characterization factor. So just you have to bear in mind that characterization factor, it measures the scarcity, the water scarcity. If it is very low, this means that you have plenty of water, you don't have any issue of scarcity. If it is high, you have an issue with the scarcity. But you have to calculate, of course. And this is very important for policies. If you are importing from, as I said, from water with low, characterization factor, it's fine. But if you are importing from country with higher characterization factor, it will be a problem because you will face an issue one day. Here I would like to show what we have published for the Mediterranean. And you can see this is very new data for 2025, and you can see the absolute national water scarcity footprint in the left, and in the right, it's by capital per, we divide by the population. So you can see here Egypt, you see Egypt, it's basically an issue of the water scarcity, but also you can see also other countries with high level, if we divide by the population, like for instance, Libya here. So these are just some examples for the Mediterranean, for the 19 countries. And once again, it's very important to consider in the policies, because having like an idea about the national water scarcity footprint, this will guide you to implement your policies and to, in particular, revise your policies of import of products, in particular, if you are importing from countries with high level of water scarcity, with this characterization factor very high. We also, established the water scarcity footprint for different crops. Here we took the main important crops: the wheat, olives, barley, rice, maize, vegetables, seed cotton, and dates. And you can see here the the trends of the different water scarcity footprint. Here in the left is the percentage, and in the right it's the water scarcity footprint in cubic meter per world per equivalent. And you can see here the differences between the different countries, between different Mediterranean countries. You see always here the Egypt, always is a problem, but also Spain, also it's an issue. Libya, Morocco as well. If we can put for the water scarcity footprint in cubic meter per world equivalent, but if it is in the left, so you can see here the importance of the crops. In particular, you see the water scarcity of maize, for instance. You can see this is very important because, as you know, maize consumes a lot of water, and the water scarcity footprint is higher. So basically what I can say here, the water scarcity footprint could be calculated for a country, but it could be calculated also per crop. So, and the fact to have this information, I think this is very important for the policymakers to revise their policies of import or export. So what we did after calculating all the water footprint and the water scarcity footprint, we did this correlation with the WEFE Nexus. And, it has been published, the WEFE or the WEFE, Nexus Index per country. So our colleague and our friend, Garrett, he published it in his last publication, the WEFE Nexus Index per country. And we try to do this correlation between the water footprint and the WEFE Nexus Index. So basically, when we are not surprised by the results, because we find very significant, correlation between even the different water footprint, the green, the gray, and the blue water footprint with the WEFE Nexus average. It's less for the water scarcity footprint because, As you know, the water scarcity footprint is basically more oriented on the blue water, and it's not, targeting, the green water footprint. And as you know, the major part of the water in the Mediterranean, because I know very well that like 75-80% is green water, which is basically the water in the soil, the water which is basically from the precipitation. The blue water, which is basically in the groundwater, in the dams, etc. This is the blue that we use it for irrigation. So the food production, it's not only relying on the blue, but also the green water footprint is important. And when I say green water footprint, it's all the agroecological, practices are relying on this important water for the food production. So what I can conclude here for the first conclusion, that there is a correlation between the water footprint and the nexus. So if you have metrics, if you have indicators on the water footprint at the level of the country, or maybe at the level of the watershed, at the level of the region, I think this could give you insights about the water energy food ecosystem index, because as you know that the water footprint is considering different components and there are hidden sometimes components in the water energy food ecosystem nexus. The water scarcity footprint is very important, and I believe that we need not to neglect the water scarcity footprint, but we need also to consider the two components, the two indicators, because their correlation with the water energy food ecosystem, in particular the water footprint, but also the complementarity between these two, indicators are very important to assess the sustainability of the farming system, but also it could be also for the sustainability of the whole region. Let me move to the second case study, and it's about the system dynamic modeling. And you have a new article that has been published, I think, 2 or 3 weeks ago. It's about how to assess the sustainability of the farming system using an indicators, a composite indicators of the water energy food ecosystem. So as you know, now we have different, indicators from the agroecology or other farming system indicators. They have a lot of shortcomings, and we need to move to the water energy food ecosystem nexus. But also to move to the water energy food ecosystem, we need to think and to facilitate for the policymakers. We need to facilitate also for the end users. And I think we cannot present like sophisticated different indicators that we need to summarize in a sort of WEFE Nexus Indicator using the system dynamic modeling. Just maybe to remind you that there is a lot of Nexus models, whether they are targeting the silo or also the Nexus. So the first ones are, dealing with the silo, the WEEP, the LEAP, SWAT, the aqua crop, crop water, and then also the market or the times. But also we have, the recently several WEFE Nexus models that have been developed, and you can see here the WEEP, the WEEP LEAP, so they connected together to tackle the water energy. We have the CLUE, we have SIM4 Nexus, we have also other tools, the different Nexus tools. But the SDM, the system dynamics modeling, it could be used for the silo, but also it's a very important tool that could be used for the WEFE Nexus. And how you will see that it's very important for the scenarios, and you can maybe consider all the components of the system. So the location of the site, it's in central Spain. It's basically the northern Spain, and you can see it's vineyards based in the region of Lleida, and the area is about 1,500 hectares. So our question here is how to assess the sustainability of this farming system, and basically we try to divide this area into different plots, because we believe that they are different, because in terms of the ecosystem, 1,500 hectares in this region. So what we did in this study, that first we did the causal loop diagram. The CLP is very important because we need to find all the interrelationship between the different components. So we have the data from the meteor data. We have the collected some data directly from the farmers. We have also the different data that we have from other source of information. We consider also the income and the productivity, and we believe that they are very important. So you can see here the different loops that we identified. So here you have for instance, the energy cost, the energy footprint, and the carbon footprint, which is basically also linked to the investment in inputs in fertilizer or pests, etc. The water footprint, and here you can see is linked to irrigation, the water usage, and also the effective precipitation, because we need to consider also the green water footprint, not only the blue one. The productivity also is linked to the harvesting, is linked to the soil fertility, it's linked also to the irrigation. So the first step, you need to establish your causal loop diagram, the CLP. Once you have your causal loop diagram, you can discuss with the stakeholders. So it's not like you can close the door and then maybe try to draw this causal loop diagram, but you need to move once you have analyzed to implement on the SDM. And one of the most important architecture of the SDM, the Stella. I think the Stella is very nice, but it's paid, and you need to think about that, because this is very important. Once you move and you have established all the relationship between your resources, you need to implement on the system dynamics modeling in the Stella, for instance. So, and then you have to implement and to establish different scenarios for maybe based on the RCPs or the SSPs, if you would like to see the impact of the climate change, if you would like to see in 30 years how will be the sustainability of this farming system. So using the SDM, you will be able to implement different scenarios, and also to calculate all the indicators, whether the silo indicators or also the composite indicators. So what we did here, that we calculate first the different silo indicators using the SDM, because all the I think here we don't have enough time to go through the details to present all different equations. First, we have the total water footprint. Well, when we said the total footprint, we have the blue and the green, water footprint, but also the gray, because for this case we don't have the gray water footprint. But also we have the carbon footprint, this second, component of the biophysical, which is basically the carbon footprint. Sometimes is even overlooked by other, agroecological or agriculture, assessment. So here we have to look to two important, origin of this carbon footprint. First off is the machine operations, or the CO2 emissions produced by the machine operations, which is basically, calculated on the equivalent kilogram of CO2. And then we have the nitrogen, which is basically the chemical, the nitrogen, which is released by the nitrogen fertilizer that you have you are using, whether it could be from the chemical, also as well from the organic. So the two should be also embedded on the SDM, on the architecture of the system dynamic modeling. The green water footprint, which is easy, I think it's not complicated to calculate the green water footprint. So here there are the formulas that, and what I can advise you, you can use the crop water. The crop water, I think, publish it, is free, it's for free. So you can use it to calculate easily the water, the green water footprint, which is based on the the amount of rainwater consumed by the crop during the season. So here all these equations, the crop water, I think it's easy, and then you are able to calculate the green water footprint. By the way, here, if you like to see, there are different publications. You can compare your results to other, researchers. There is like a recent publication, a database even published all the green and water footprint published by Merheb on 2024, last year. So you can compare your results, because this is an estimation that has been done by a very nice publication by Merheb all last year. An important step to calculate the composite indicator. Once you finish all your silo indicators, of course, you need to think about the income or the social component, the socio-economic component. So once you have all your components, the most important step is to normalize and the different indicators, because without normalization you cannot calculate an appropriate composite indicators. So be careful, because it depends on the value, it depends on the criteria. So if the indicators is like positive, if I can say, you can use the first one. If it is more negative, like the expenses, for instance, or the costs of production, in this case you have to do the other way around, the maximum minus the value. So here the normalization depends on the the contribution of the indicator, whether it contributes negatively or positively. It depends, of course, on the indicators. It could be the cost, for instance, cost. If it is too high, so you have to use the second one. Then the second one, and I would like to highlight it here, you need to establish the weight of the indicators. This is an important step. So we use it, and all the researchers, they use it, the critic methodology. So the critique, which is the criteria importance through inter-criteria correlations. It's very important. We have, let's say, different methodologies to calculate the weight. We have the mean weight, the standard deviation, but they have the variance methodology. But the critique, I think it's very important, it has been used by several researchers. And even the critique, you will see that now we improve the critique, because there is some shortcomings for this critique methodology. So very quickly about the critique methodology, and I advise you to use it if you would like to establish a WEFE Nexus composite indicators. So it's not complicated. You have to calculate your standard deviation for each criteria. And then this is the most important, is to do the correlation between the criteria, every two together, every two criteria, like water and energy, or water and food, or water and land, whatever. So this is very important. And this is the shortcoming, by the way. This is shortcoming of this critique, because they are using the linear correlation of Spearman. And if the correlation is not linear, this is what I would like to also highlight in the second slide. You need to think about another methodology, which called the credit, not the critique. So the third step is to calculate or to measure the conflict created by criteria G with respect to the decision situation defined by the rest of the criteria. So this is the sum of 1 minus, this is the correlation R. This is the correlation between the criteria. You see, you have to see 1 minus, and you have to do the sum of all these conflicts. And then just you can calculate for each criteria. You have the standard deviation that you have calculated, you have different criteria, and you have the sum that you have calculated, which is basically the sum of 1 minus the correlation that you have calculated. And then, which easily you have to quantify, you have to multiply the standard deviation by this number, this total. And then you will find this quantitative information. You see here that this is the different value, and then the weight. It's basically very easy. It's you have to put the value that you have obtained by the total of the total, and then you can establish the weight of each criteria. So maybe you are asking why we are using this critique methodology, because if you will use the stakeholder, for instance, it will be subjective, and maybe it will not be appropriate to establish a different weight of the criteria. It's better, I think this is the methodology, we're very well known, I think it has been, used by different researchers. But the main issue, as I said, the linearity of the correlation. So now new advanced methodology is the credit. So the credit, it's like a new methodology. It has been published last year, by the way. So it's called the criteria importance through inter-criteria dependence. So the only issue here, so for this critique, is the linearity of the Pearson correlation. This is the only way. You remember when you are doing the correlation between the different criteria, you will be using the Pearson correlation, but the main problem that the Pearson correlation may not address non-linearity in some scenarios. If you are not in the linearity, so this critique could not be used, and I advise you to see whether your criteria are linear or not. If it's not, so then you have to use the the credit methodology, which basically I have some example here, but for the sake of time, I advise you maybe to read it a bit because it has been published last year. I haven't seen any publication using the credit, but I think it's very important to think about using. So the main component here of the credit is they are using the another correlation, and another correlation, it's called the distance correlation. So we are not using the Pearson correlation, but we will use the distance correlation. And I think once we use the distance correlation, this will correct and maybe will, let's say, bypass, if I can say, the linearity, which basically the most important shortcomings of the critique methodology. We have used the critique in our methodology, but we have considered the shortcomings of this critique, but we don't have any issue with the linearity with our criteria. So as you can see here, we calculated for this farming system, this case study, and we divided this farming system in two different zones. We calculated the water footprint, as you can see here, in cubic meter per ton, and the water footprint is now ranging between 500 and 700 cubic meter per ton. So this is basically logic according to what has been published and according also to what we have seen in the region. So you see here that maybe the high zone here we have a lot of water footprint is if we compare to the two others, which are a little bit very similar. And also we calculate also the for different varieties, because here we don't have time to present all the results. The carbon footprint, you see here that we have calculated also the carbon footprint for the three zones, and you can see the differences between the different the different zone in terms of the carbon footprint. And we presented, by the way, the results to the to these farms, and I believe that they found it like very useful for them, and you will see now the index. The energy footprint as well, you see here the high zone is always having the highest footprints from water, the carbon and energy as well. And we have also calculated the other also silo indicators. Now, after doing this, standardization, after calculating all this weight, now we have the WEFE Nexus Indicator for this farming system, which we have divided into three zones. So you can see that a difference, and we highlighted to the farmers that you have an issue in this zone, because the here the WEFE Nexus it's good, it's excellent, because if the WEFE Nexus is higher, so you are in the sustainability. If it is less than 0.5, you are not in the sustainability. So here we can say that the two zones could be considered as good, in particular the low zones. But here we are in the moderate WEFE Nexus indicators, and we have an issue here with the sustainability for this zone. So they are using a lot of energy. They are pumping maybe the water for irrigation. So now I think after the study, now they are focusing on how to increase or to improve the sustainability in this farming system. Just maybe to come back here, the question maybe sometimes for the farmers, we prepared like a sort of tool. We call it AgriMod WEFE Nexus tool. It's easy. You can just introduce your data, and the software could calculate the WEFE Nexus Index. Because in the SDM, in the stellar architectures, there's a lot of equations. It's a little bit complicated for the end user, for the farm, for the policymakers. But now we have produced like a sort of an easy user-friendly like tool that could be used to just to import data or put the data. So this user-friendly tool could calculate easily the WEFE Nexus indicators. So what I can conclude here that this is very important. The SDM, according to my experience, and we used other modeling system, but the system dynamics modeling appear like robust because first off, it could maybe consider all the components of the system. You can put all the equations that you need, but also you can establish scenarios. You can use the RCPs or the SSPs. So it's open, it's dynamic, and it's flexible to be used. Then the SDM, if we can compare to the other farming system sustainability that what has been used in the agroecology index, or maybe another assessment at the farming level, there are a lot of shortcomings, as I said, and here it integrates all the components, but also it could assess the trade-offs. We use it, by the way, the SDM and the WEFE Nexus Indicator to assess the trade-offs and the synergy between the different resources. So what I can conclude here, and of course, if you have any question, please feel free to ask or you drop it in the Q&A. Assessing the farming system, it's not it's not easy. We cannot maybe try to focus only on the biophysical resource and overlook the social and the economic component. This is very important. The agroecology index that I have highlighted from the tool of the FAO, like the TAP, for instance, which the tool for agroecology performance evaluation, or the OASIS, or also the main agricultural structure, or also other indicators. They are very good, but we have a lot of shortcomings, and we need to think how to consider not only the fact that they are using different components, but there are a lot of shortcomings, in particular when it comes to the integration, but also sometimes they are maybe overlooking, and they are neglecting some components of the system. They are more, sometimes they're giving more scores on the ecosystem, and they are maybe neglecting the other components. So we have to be careful. We found, by the way, a good correlation between the main agriculture, structure, the mass indicator of the agroecology with the WEFE Nexus. We find a good correlation, but with we did some experiments to correlate the top, the top of the FAO with the WEFE Nexus, and the correlation was not like very significant, and it's not like high because the top is more focused on the farming system, more focused on the ecosystem and the ecological practices, and is neglecting other components. So what I can conclude that it's better to focus more on the tools of the water, energy, food ecosystem, the system dynamics modeling, the SDM opened a lot of windows, and I think it could be a very important a tool to assess the sustainability of the farming system. The SDM, if you will be using the stellar, for instance, architectures. It's complicated, I know, but you think about a user-friendly tool that could be maybe used by the farmers, and it also could be used by the policymakers. So we believe that the WEFE Nexus Index is an important, indicator for this to assess the sustainability of the farming system, but also we should not neglect the other silo components. If we would like to see the issue, we should look at the trade-offs and synergy. we should look also at the at the scenario and the trends of this index for the future. It's basically a powerful tool, and I advise you to to deep dive and to use these kinds of tools like this WEFE Nexus Index, the SDM, and the Nexus in general to assess the sustainability of the farming system to the climate change, because our challenges, whether in the Mediterranean or also all over the world, is to how to assess the farming system to the climate change, to produce more with less resources, but also to preserve the ecosystem, and also to make the system efficient for the next generation. With that, I would like to thank you so much. And of course, if you have any questions, please go ahead. So you can drop your question in the Q&A. And I believe, Serena, that we have questions. I did not check, but let's go to this the discussion. We have 15 minutes to discuss. Back to you, Serena.
Yes, thank you so much, Ali. That was really comprehensive and interesting about all the different indicators. There are 2 comments in the chat from Fleur and Daniel. It's probably best, let me read them there, but if the others could add their questions to the Q&A panel. So let me read, because let me read here what Fleur said something about the development of social sustainability indicators using FADN, and that will be replaced by farm sustainability data network. So I guess that's just for information. Yes. Daniel had a long comment. He asked, when speaking to stakeholders in the viniculture context, did you have the impression that they are more open to Nexus approaches than in other agricultural fields? Okay, that's an interesting question.
And this is a very, very interesting question. When you highlight, and maybe sometimes you are highlighting the WEFE Nexus, and I think we experience it even here in Spain. So I think the first, reaction of the farmers or any stakeholders, they have no idea what's this Nexus, and they have no idea. They know maybe the agroecology. If you can maybe discuss with them, the agroecology, they have the idea. But if you discuss with them the water, energy for the ecosystem, the first reaction, it looks they're a little bit very surprised. What's this approach? And they have no idea how to do. But that's why, the building capacity is very crucial for all these stakeholders, from, the end user to the policymakers, because without, training, without, capacity building, I believe it will be very difficult to implement, the Nexus approach in the ground. And by the way, this is what we are now facing in the Mediterranean. Even if we are like funding a lot of projects on the WEFE Nexus, but still we have some resistance on understanding the WEFE Nexus. Yes, I think you are right. It's not easy to deal with this important concept.
We don't yet have another question. Oh, there's another one coming in the chat. Could you repost your question in the Q&A, and then let me ask Ali a different question. I saw a literature review, systematic literature review the other day. This was more about companies who also obviously do economic, social, and environmental indicators, and which they have to report on. And the comment there was that they tend to measure being less bad instead of measuring a contribution. So would you say the same is true in agriculture, or is agriculture maybe a bit different? Are they also measuring about being less bad, or is it more about, is there also something about making a contribution maybe to the ecosystem?
I think the two, we need to assess the two components, whether we are maybe doing bad for the system, because the fact in the farming system to use like a lot of like pesticides, like fertilizers, and then we are maybe impacting the ecosystem, and we have like carbon, footprints. This is the bad thing, but also in the other component, if we implement nature-based solution, if we implement adaptation solutions, if we maybe foster the agroecology, then we can make some very important things for the system. So we're improving the ecosystem, and I need to improve and to highlight the two. This is basically the trade-offs and the synergy that Serena, you are dealing with. So the trade-offs, if you are making bad, because it's very important, you can increase the productivity using like net nitrogen and using different source of fossil energy. But we are leading to another trade-off or model in the system. This is the bad thing. But also the synergy, if we are improving the ecosystem, and I think these are the main important components of the water energy food ecosystem, to assess the trade-offs and the energy and try to improve the or maximize the synergy and reduce the trade-offs. They do these smart things and increase or improve these these good things.
Yeah, you can't measure the one thing. It's always about the optimizing a solution.
Yeah, like the carbon sequestration, for instance. The carbon sequestration in agroecology, and I think sometimes you have to need to think about how this, the added value of agroecology, of maybe sometimes you are thinking about other systems that, like regenerative agriculture, that are sequestering more carbon in the soil. This is added value, and this is the benefit, and we need to assess the carbon sequestration, for us. Sometimes it's a little bit overlooked by a lot of studies. And this is one of the positive things that we are implementing. And the Nexus is behind this idea, is how to can maximize this energy, how we can have more added value without impacting the entire ecosystem.
Then there's another interesting question. It's from Karl-Heinz Beger. In the WEFE Nexus Indicator system, I miss the eminent role of the soil as the fundamental basis for the sustainable production of agricultural crops. What do you think about that? So I'm not going to read the whole question. It's a long one, but maybe your opinion on that.
Yes, I think she highlighted the soil, which is another resource of the Nexus. If you are targeting, the resources Nexus, I think Flor is here, or Daniel. Now we are maybe focusing more and more on the resources Nexus, so without neglecting any resources. So like if you can see water, energy, food ecosystem, where is the soil? The soil should be an important component, and I think if you are assessing the components of the soil or the parameters linked to the soil, you should consider them. And if you establish your composite indicators and you have like a different, dimension of the soil, whether it is be the carbon, it could be only also the physical-chemical characterization, etc. You have to demonstrate to put it as like a component. And when you do this weighting using the credit or the credit, you have to maybe provide them more importance. You will see it will be like the weight will be higher. So if you have the resources, it depends on case by case. You have to consider all the parameters. And more importantly, if you are like implementing a sort of WEFE composite indicators, you need to target all the different resources and do not neglect any resources that you are focusing on.
And I like how you pointed out that the system dynamics modeling can then do it in a very dynamic way, so that you can always keep on changing. Then there's a question here. In some point of the presentation, the water resources were categorized in blue, green, and gray. But then in a following slide, the calculation equation included only blue and green without gray.
Yes.
So you know exactly where that is?
Yes. This is very important. Very good question. So when you calculate the water footprint, you have to check in your case study, or if you have some gray, because the gray water, if you are maybe it's the what has been used by the system, if you are preparing the water, the epuration, the treatment of the water, and this water, you have to consider this calculation in the total of the water footprint, because the water footprint is the green plus the blue plus the gray. And there is formula, by the way. So there is a formula that could be included in your SDM, on your model to be considered. So case by case, if you have and this gray water footprint you have maybe in agriculture, and you are losing a lot of water. If you are using a lot of water, and then this drainage water and this flow water will be used, so I think it's better to consider this gray water footprint in your analysis. And we have equations, and you can embed it in the system in the SDM. I think it's easy. It's not complicated at all.
I had a question also about the water, not the water security, the water footprint, but maybe it was also for the water security. I think you showed figures for 2010 and 2019. And
Yes.
if I was not mistaken, all those values went, or many of them went down from 2010 to 2019.
Yes.
Do I remember that correctly? And why? Were there some interventions, or did this just happen by itself? Probably not.
Yes, we compared two different periods, and I believe there is difference 10 years between the two different periods, and we want to see if there is any advancement in terms of the water scarcity footprint. You mean it's not about the water footprint, because there is difference. So, and in terms of the water scarcity footprint, of course, there is a change all over the world, because as you remember that the water scarcity footprint, it's basically calculated around the blue water footprint to be multiplied by the characterization factor, and the characterization factor is linked to how much water we have and how much water we need for our consumption and for the environment. So if after 10 years we have an issue with water, maybe we have less precipitations, and we have less water. We have in particular blue, more again. So we are in a difficult situation. So basically, it could be reduced, and we have to be careful, because when we calculate the water scarcity footprint, we need to calculate it also to report by inhabitant or per person or equivalent. So because sometimes it's the population,
yes.
And I have not seen like studies calculating the water scarcity footprint. We have the water, the water index, how much water per capita, like 500 or 1,000, and we have some thresholds, but we don't have thresholds, for instance, for the water scarcity footprint. I a little bit surprised. I don't know why we are not considering the water scarcity footprint, and why we are not like putting like sort of threshold like we have for the water index. Yeah.
There's a last comment, but I don't know if you can respond. It looks like there is a longer discussion about that. Professor Feger disagrees that the imminent role of the soil is somehow split into singular static parameters. The modern concept of soil health, jumped down, is more than functioning and the interactions in the agro-ecosystem and resulting synergies. So let's just consider that comment and move on to the last question. This is the last one that we can take. Can we build on this WEFE concept in resource scarce areas at the farm level? This is the question.
Yes, I think we need to validate now this concept, because we have implemented in a case study of 1,500 hectares. So basically, it looks like we have different farms. It's not only small farms. We have like more than 40 farms. We have implemented. I think it works very well. Of course, we are more than happy if we would like to upscale and use the same concept in other different systems. So we, of course, we are available to implement this concept and these indicators in different, it could be vineyard or any other, farming system. Yeah.
Great. So I'm sure they can get into contact with you or look at your publications. The video will also go up on our YouTube channel, on the Nexus Seminar channel, which you can find on the UNU Flores website. So with that, I would like to thank Ali very much for this very insightful presentation about the indicators. And as you could see from the comments, a lot of food for thought. I don't think we are at the end of the discussion and the conversation. Thank you so much.
Yes, thank you so much. And please reach out to me You have my address email in case you need any clarification, because it's impossible to present everything like in 1 hour and 15 minutes. But of course, I am more than happy to share with you if you have any questions, any maybe recommendation, if you like to upscale or maybe to use this concept, etc. I am personally more than happy to be in contact with you and to reach out to me whenever you want. And thank you again, Serena, for the invitation.
Yes, and thank you also to the participants and their interactive participation. Thank you. Okay.
Thank you.
Bye-bye.
Bye-bye.